Evening, ladies as well as gentlemen. Papa Boris here with some more Human Resource Machine. This is puzzle number 37, the Scavenger Chain. And I think I mentioned this before, but puzzles 37 and 39 in this game are actually pretty easy. They're rather simple puzzles because they use some advanced concepts, and like I said before, typically when there's a difficult programming concept, the puzzle itself isn't that hard. So here we're using what's called a linked list. Basically, each of these pairs on the floor has two components. There's a data, which is the letters, and then there's an address, which is the numbers. So your goal on this problem is to, or in this puzzle, is to output the data and then read the data at the next address until you get to the negative address. So just to illustrate that, because I know it's kind of hard to explain with words, but it's easy to understand with an example. This first number is 0. We're going to put the E in the outbox because E is at address 0. Then we're going to read what's at address 13, which is the S, and output it. Then we're going to read what's at address 3, which is the C, and then output it. Then we're going to read what's at address 23, which is an A, stick it out. Address 10 is a P, stick it out. Address 20 is an E, stick it out. And then when we get to the -1, we're done, because once you hit the negative address, that is how the designers are telling you you have finished doing all your work. So it's not really that difficult. The only hard part is really understanding this like linked list structure, but it ends up being pretty simple. We just take the value in the inbox, which is our first address, and we copy it to the address. Then we copy what is at that address and stick it in the outbox. After that, we bump the address up by 1. So initially we were given the address of a data point. When we bump the address up by 1, we're going to get the next address. So like 0 is an E, and then we bump it by 1 to get a 1. 1 is our next address. So what we do is we just grab that next address, and we need to check if it's negative, because if it's negative, that means that we're done. So we just have to go all the way back to the beginning and take the next data point. But as long as the next address is not negative, we simply make it our next address and copy from there, just like repeating the process that we used for the value in the inbox. So like when we're given a 0, we're going to put it in the address field, copy the E, output the E, then bump the 0 to a 1, which will make us copy the 13. 13 is not negative. So then we're going to repeat back here, which will be just as if we had been given a 13 in the inbox to start with, which will point us at this S. So the whole thing is escape, but if you don't have the E, you get scape. If you don't have the S, you get cape, and then ape, and then pay, and then just an E. So there's lots of like words within words in this one. Let's take it just a step at a time at the beginning just to show you. 0 is our first address, so we copy an E, stick it out, make the 0 a 1, and then we look at what's there. That's our next address. It's not negative, so we got more work to do. So we just make that the next address, copy it, and you get the idea here. So there's escape, albeit backwards. And then the next time we just got ape. And that's that. So really that's all there is. I don't know if there's some crazy tricks people use to improve on this, but this is clearly what the designers intended. Let's take a look at the other puzzle in this pair, the Recoordinator. This one's a little bit trickier, but it's really, I don't think, one of the hardest puzzles in the game, which is kind of weird because it's like the third to last. So anyway, here what we have to do is we need to send the coordinates of the number in the file, column first, row second. So to illustrate, 10 has the coordinates, like this is the spot 10 right here on the floor, it has the coordinates 2 and 2. So we'd output 2 and 2. 3 has the coordinates 3 and 0, so we'd output 3 and 0. So that's all we have to do here is find out what the coordinates are, and the designers were handy enough to give us these variables, or these numbers, 0 and 4. 4 is extremely helpful because, of course, there are 4 spots horizontally and vertically, so 4 is a very useful number to have. Now I'm going to have just a couple of variable names here. We're going to go ahead and call this 0, and call this 4, just so I always know when I'm using one of those. Then we're also going to need to have a counting variable, good old CNT, and a temporary variable, will be needed later as well, as you shall see. So here's what we do. We, first of all, start by copying from 0 and making it our count, because our count always starts at 0. Now, we take a number from the inbox, and we subtract 4 from it. This is actually really similar to that modular division, and just the division puzzles in general. Basically, because division means you just subtract the smaller number until you get negative, and then that's when you know that that's how many times you were able to fit the thing in. So we subtract 4. If the result is negative, that means that we actually had it right the first time. So we add the 4 back, and that's actually going to be our column. So I know that might seem a little bit weird just to see the code here, but let me show you with an example. Alright, we're just going to read through part of this. So I take 10 and I subtract 4. It's not negative. Oh, I should really, sorry, before I show you this, I should actually say what happens if it's not negative, so then we can actually do this right. If it's not negative, then we're going to go ahead and copy it to our temporary variable so we can save it, bump up the count by 1, and then we're going to get our temporary variable back. The reason that we have to do this is that when you do the bumping operation, it overrides whatever's in your hand, so the new value goes into your hand. This is a case where that's bad, because I'd really like to just bump the count and keep the number in my hand, but I can't. There's no way to do that. So anyway, after this, we jump and repeat the process of subtracting 4. So okay, let's do it now for real this time. We take an 8, we subtract 4. It's not negative, so we save our 4, bump the count, pick the 4 back up, jump, and we subtract 4. It's 0, still not negative, so we save that, bump the count, pick up the number, subtract 4. There's our negative, finally. So we add 4, and then we output it. And lo and behold, look at this 8. Its column is indeed 0. So basically, the column of a number is the remainder when you divide that number by 4. Like 9 divided by 4 is the remainder of 1, 10 divided by 4 is the remainder of 2, 11 divided by 4 is the remainder of 3, and so on. That just always works because there are exactly 4 columns. If it were, if there were 5 columns, that would be the remainder when we divide by 5. Okay, obviously we're going to write the rest of the program now, but it's actually not too hard from here, because at this point, all we have to do is just copy whatever our count was and outbox it, because the counting that we were doing was actually our number of rows, believe it or not. Because basically the number of times you can divide by 4, not the remainder, but the number of times is your x-coordinate. Like 4 fits into 8 twice, 4 fits into 11 twice. Once we go here, this is actually 12, 4 fits into 12 3 times. So basically, the coordinates happen to be both the value and the remainder when you divide that number by 4. It's kind of nifty how that works. So let's just do this fast, and that should be it. I guess I should have called this like column and row. That would have maybe made it a little bit easier to understand, but that's all there is to that. So this is, again, seemingly the solution the designers intended. All right, a nice short video here because the other puzzles that are left are all really fucking difficult, so I don't want to do one of them now. In fact, I'm going to have to look up how to do these last two because they're so difficult. I wasn't able to solve those in any kind of optimized fashion, and we also need to come back and do this one at some point. Those are probably each going to get their own video. All these remaining 4, I think. So anyway, thanks for watching. Hope you enjoyed it. Please like and or subscribe, and we'll see you again soon. Take care.